So in today's class, we did a little bit of review at the beginning on domain, x-intercepts, and average rate of change, but then the rest of the lesson was really focused on function transformations, and I want to keep it going with function transformations in the video part of this lesson today. So I first want to show you another way you can approach sketching graphs of transformations. So when you get a function that is a transformed version of a parent function, like this one we have 2 times x minus 3 squared minus 2, okay? A way to graph this is to consider it as a transformed version of this original x squared graph, right? So a good way to do this is to focus on the vertex, which normally is at 0, 0. And we can see that this function is going to be shifted, the graph is going to be shifted 3 units right, and then 2 units down. So when I take that vertex at 0, 0, I go over 1, 2, 3, down 1, 2. Okay, so this is my new vertex. So now the next part of this that we have to address is this 2 out front, right? This is making our outputs 2 times bigger. It's making our graph 2 times steeper. So what we have to do is consider where these other points are in reference to the vertex. So when I look at my original graph, okay, normally from the vertex I travel 1 in the x direction, 1 in the y direction because I have a point at 1, 1. So from my vertex, instead of going over 1 up 1, I'm going to go over 1 up 2 because I've made my outputs twice as big. So now I'm going to go over 1 up 2 and put a point, and then over 1 up 2 and put a point. Okay? Now, because this is x squared, right? It's getting steeper and steeper and steeper over time. So now we need to consider this next point, how far away it is from our vertex. So we go over 1, 2, up 1, 2, 3, 4. So normally we were 4 away in the y direction from our vertex. So now we need to double that. So we're going to go over 2 and then up 1, 2, 3, 4, 5, 6, 7, 8. So now we have our point up here. Okay, I need to count that out again. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then it's symmetrical, so we have the corresponding point over here. So then in these types of problems, to make it clear, I'd like you to label 3 points. So we have the 3 points labeled. We have our vertex at 3, -2, and then over 1, up 2, over 1, up 2, label those points, over 2, up 8, over 2, up 8. But just like we did in our lesson today, we can track the original point to show how that still is a way to transform a function. So if I know I have a point at 2, 4, and I have the transformation, where is that point going when it gets transformed? Okay. Well, we know that the input was 2, and then what happened to our inputs? Well, we shifted the graph 3 horizontally to the right, so we're actually going to add 3 to our input. So our new input is going to be 5. Okay, and then what happens to the output, which was 4 in the original graph? Okay, well, what happens to the outputs? The outputs get multiplied by 2, and then we subtract 2. So what we're going to do is we're going to take our original output and we're going to multiply it by 2. So we do 2 times 4, which equals 8. And then after we multiply it by 2, we now have to subtract 2. So we do 8 minus 2, which equals 6. So then our new output is at 6. So we can see how that point at 2, 4 got shifted to 5, 6. Okay, 2, 4, now 5, 6. Let's do another example. We have a transform square root x function. So you may remember, I'm just going to draw like a rough sketch of this. It looks like this, right? It starts at the origin 0, 0, and then it shoots off into that first quadrant. So this point at 0, 0 is again going to be transformed by this +3 and this -1. So when I graph this, I see that my function is going to be shifted 3 to the left and then down 1. So I'm going to go over 1, 2, 3, and I'm going to go down 1, and then that's my new starting point of this graph. Okay, and this is at -3, -1. Okay. Now, normally in the square root x function, we would be going over 1, up 1 to that new point, and then we'd be going over 1, 2, 3, 4, up 2 to get to that point, right? So we would normally run by 1, rise by 1, run by 4, rise by 2. But we're multiplying our outputs by -2. So what we got to do is when we travel 1 in the x direction, we're actually going to have to go down 1, 2, since normally we go up 1. We're multiplying that by -2. So we're going to go, we're going to travel 1 in the run direction and then 1, 2 in the rise direction. Okay, so what's that point? That is at -2, -3. Okay. And then normally on our square root x function, we would go over 1, 2, 3, 4 up 2. So now when we go over 1, 2, 3, 4, we're actually going to go down 4 because we would normally have our rise be 2. We're going to multiply that by -2. So I need to add another tick mark here. Okay, a couple more. Okay, so I'm going to go from my starting point, I'm going to go over 1, 2, 3, 4, and I'm going to go down 1, 2, 3, 4. Okay, so where's that at? That's at 1, -5. Okay, and then I just need to draw my curve through those points. I did an okay job. Let's try again. That's better. Okay, so there's our transformed function right there. Okay. So what about in table form? So now we're just looking at a table, no graph. I'm giving you a table of cube root x, right? The cube root of -8 is -2. The cube root of -1 is -1. And what we want to do is transform this table, this f of x table, so that it's now f of x plus 5. We see that input x plus 5, and we see that this graph is shifting 5 to the left, which means we just need to subtract 5 from the inputs. Now, why do I subtract 5 when it says plus 5 here? So I'm actually subtracting 5 from the inputs. This is a common question. So when you see f of x plus 5, you should think that x plus 5 is replacing the original input. So if my original input is 1, I'm going to equate that with x plus 5, because x plus 5 is going to replace 1. So then if I solve for x here, I get x equals -4, right? So the input 1 has shifted 5 to the right, to the left. The input 1 has become -4. Okay, so then over here, we're going to replace another input, -8, with x plus 5, because that's what we're replacing our inputs with. Again, if we solve for x, we get that the new input's now at -13. So that -8 has shifted 5 to the left. I need to fix this. Shifted 5 to the left, and the new input is -13. So in our table, all of our inputs, -8, -8 that we have in our table, are just going to be, we're just going to subtract 5 from them. So now we have a point at -13, -2, -6, -1, -5, 0, -4, 1, and 3, 2, just subtracting 5 from all of our inputs. What happens to the outputs? Nothing, because all we're affecting is our inputs by replacing the inside with x plus 5. The outputs are staying exactly the same. So now this is our new table. So we can make it a little bit harder now. We're going to use this transformation, -3 times f of x plus 5 plus 2. So our function is going to be -3 times the cube root of x plus 5 plus 2. So we're going to make a table for this. So first we need to consider what's happening to our inputs, what's happening to our outputs. Once again, our inputs are only affected by this x plus 5 in here. So they're being shifted 5 left, so we're subtracting 5. And then our outputs are being multiplied by -3, and then we are adding 2. Okay? So first let's affect our inputs. We're going to subtract 5 from all of our inputs. So we have -8, we're subtracting 5, that's -13. -1 minus 5, -6. 0 minus 5, -5. 1 minus 5, -4. 8 minus 5 is 3. Okay? So that for our outputs, let's do a different color here. Our outputs are here, -2, -1, 0, 1, 2. Okay, we're going to multiply by -3, and we're going to add 2, right? So that output -2, we're going to multiply by -3, and then we're going to add 2. So what's -2 times -3? That's 6 plus 2, that's equal to 8. So our new output up here is going to be 8. Let's do another one, -1. So we're going to do -3, -3 times -1, and then we're going to add 2. What's -3 times -1? That's 3 plus 2, that's equal to 5. So our new output is at 5. Okay. You can try to do these last three, 0, 1, and 2. Pause the video, try it out, and then unpause to see it filled in. So here's our filled in table. And like if you're picturing this graphically, again, you had a point at 8, -2 that has now been shifted to -13, 8. You had a point at -1, -1 that's now been shifted to -6, 5. So if we go back and look at the graph, here is the original graph of cube root x. Okay, cube root of 1 is 1, cube root of 8 is 2, cube root of -1 is -1. This forms out this curve. Okay, if we perform all these transformations where we're shifting it 5 to the left and 2 up, okay, 5 to the left, 2 up, and then we're flipping it vertically and we're making it steeper by multiplying by 3, this is the result. But we can see how these points are transformed. If you remember from the lesson today, we showed how 8, 2 is transformed into 3, -4, right? We just went through that process again strictly by looking at tables and not by looking at graphs. But we can always pull it back into the graph and look at the graph context as well as the table context. All right, that's all I have for function transformations.